trigonometry. That's what this is. I think you've already had right triangle trig. And this is very basic stuff, right? I can't spell. Right triangle trig. And most of you should have seen this before. Trig. So, and that's the thing with SOHCAHTOA, which we already kind of did already. S-O-H. Do you know what this stands for? Have you seen this before?
Yeah.
So, I don't know, some teachers don't even teach that, but SOHCAHTOA means, so if you have a right triangle, which I'm going to draw a picture of a right triangle using my tool, okay? Here's a right, that's how I want it, so look at that. That's a pretty good right triangle. Okay, so if this is the right angle here, and you have to be aware of where you're standing or where your theta is, okay? So in trig, you graduate from having things called A, B, and C to theta. You usually call angles, or that call them Greek letters. So if I'm standing over here, sine of that angle, sine of theta is the ratio of the opposite side to the hypotenuse side. So according to this triangle, this would be the opposite side, and you know from that this is the hypotenuse side, right? Yes? Well, how many of you know this already? Most of you should. Okay, so cosine, so theta equals ADJ, adjacent side over the hypotenuse. Okay, so the adjacent side is the one next to the angle that is not the hypotenuse. And the tangent is tangent, that stands for, this stands for cosine, this stands for SINE, that's just abbreviation. Tangent is equal to the opposite side over the adjacent side. All right? And then, so if I'm over here, those things flip, right? So if I'm standing over here and I call this, if I call this theta, then this is no longer the adjacent side, right? That's the opposite side, and this is the adjacent side. So it depends on, but the hypotenuse is always the hypotenuse, which is always the hypotenuse. Cosecant of theta, so cosecant, CO, is the reciprocal of sine. And that's equal to hypotenuse HYP, HYP over opposite. So these are not cofunctions, these are called reciprocal functions because you flip them over. So sine and cosecant are reciprocals, okay? Cosecant, how many of you know that? Not as many, okay? So this is, that you should know, that's called cosecant. And cosine and secant are reciprocals. So cosecant of theta, I should have more room. Can I move this? That's equal to hypotenuse over adjacent, HYP over ADJ. You flip those. And cotangent, I guess I should write them all. Cotangent is equal to, cotangent of theta is equal to adjacent over opposite. Now when I'm referring to these things, I'm talking about a ratio of the sides, okay? So for instance, when this angle has a certain measure, the ratio of this side to that side has a certain number with it. Yes?
So are those just, are the opposite ones just the second tan or second cosine?
No, they're not.
No? Okay.
No, that's when you want to find the angle. So no, they're not just the second. So that's the other thing, which we'll learn tomorrow. But if you want to find the cosecant, for instance, of 30 degrees, and you're in your calculator, you have to know that we haven't talked about well, you can, cosecant of 30 is equal to 1 over sine of 30, okay? So that's how you do it on your calculator, Tracy. So if you want the cosecant of an angle, or the secant of an angle, you put, it's 1 over this will give you that angle, right? Because if I want to flip a fraction, say I have 3/4, right? That's equal to, so if I want to flip this over, and I go 1 over 3/4, that's exactly the same as 1 times 4/3, right? Right, so if I want if I want the value of the reciprocal, I put 1 over the function to get the reciprocal function. Yeah? No?
Why would you do a secant or cosecant?
Why would you want to do it?
Yeah.
They come up in applications of different things, okay? Such as, I don't know.
What does that tell you though?
Tells you, so if you want the secant of, so say you want the secant of, oh, you know what I'm doing, 90. These are all for angles less than 90, by the way. Secant of 85. If that angle is 85 degrees, then the ratio of this side to that side would be some value. Okay, so if I even we'll do some solving triangles. For instance, okay, and we haven't talked about the cofunctions yet, which I'll talk about. So these are called the reciprocal functions, cosecant, secant. So, but they're also cofunctions. So you got to be, so sine and cosine are cofunctions. Tangent and cotangent are reciprocals and cofunctions. And I'll talk in a minute what the relationship is with the cofunction. So say, why would you ever want to know this? You took geometry.
I'm not asking why you would want to know it, but what does that tell you?
Well, we're going to see in a minute. Okay. So where's my triangle tool? Where are my triangles? There it is. Okay. So here's a triangle, and say you know that this side is 5. And this side is 13, and this side is we don't know. We'll call it. Oh, then not that side. This side is 13. Sorry, this side is 13, and this side is I don't know. And they say find the value of all six trig functions. Trig, and we'll call this theta over here. Trig functions. What's the sine of theta? It's b over 13. How do I find b? Yes, you have to. So sometimes you'll have to use the Pythagorean theorem. Does anyone know what b comes out to be? This is a special right triangle. Anyone know?
3, 4, 5.
No, it's not a 3, 4, 5. It's no one knows.
7.
Not 7. I don't think. Subtract 25 from each side. Subtract 25 from each side. B squared equals 144. What's the square root of 144? 12. So this side comes out to be a nice 12. That's called the Pythagorean triple when everything comes out even, right? Okay, so now so first I have to find this side, and that side's 12, and then I have to find my 6 trig function. So what's sine of theta? Opposite over hypotenuse. Come on. 12 over 13. What's cosine of theta? Cosine of theta? 5 over 13. What's tangent of theta? Whoops, that should be a 13. Tangent of theta? 12 over 5. So then I want to find the reciprocal functions. Cosecant of theta, I just flip that upside down. Okay? Secant of theta, flip that upside down. 13 over 5. Okay? Cotangent of theta is equal to 5 over 12. Is that hard? Any reason or problems or anything like that? So what does this tell you? It tells you the ratio of these sides. When that is that ratio, this angle, when all of those things have that ratio, that angle will have a certain measure. Okay? So to answer your question, we're kind of getting ahead of it a little bit, but you already know this, I think. So first I want to be in, if I'm looking at my calculator, hello, view, always in front, and then I want to go to mode. So in this, you got to be aware, really be aware of what mode you're in, okay? most of these problems, well, they won't always be in degree mode, but now I'm in degree mode. So if I want to know what angle has a sine of 12 over 3, that's where you use this second, okay? So if you go second sine of
How would you do it
12,
on paper?
you would, you can't. You have to use a calculator, okay? Inverse sine of 12 over 13, that will tell you that angle is about 67, that's about 67.38 degrees. So if I know that the ratio of the opposite side to that side is 12 over 13, I will know that angle. I could also find it using secant or cotangent. For instance, so maybe I want to know what that angle is, and all I know is the ratio of this side to this side. The ratio of this side to this side is 12 over 5. The way I would put that into my calculator is second. Then I go second cotangent of 5 over 12. So I'd have to know that if I know cotangent is 5 over 12, that means that the tangent is 12 over 5. So I'd have to go second tangent, whoops, wrong thing, my phone's at it. Second inverse tangent of 12 divided by 5, okay? And then I should get 60 same angle, right? So when this ratio is 12 to 5, or that ratio is 5 to 12, or this ratio is 12 to 13, that angle is always going to be 67.38 degrees, and that's where you would use it. All right. Well, so then they have this stuff on finding exact values. So let's get rid of this.
Wait, could you get the same value using cotangent or secant?
Yeah, but you don't have a cotangent or a secant button on your calculator.
Yeah.
So you have to first take the reciprocal and call it cosine, you see, if you're going backwards. But if you're going forwards, then you go 1 over the sine of that, doing that one. So, look, I'm doing okay here. So, exact values, that's where you use the unit circle. But these, when you're doing right triangle tricks, when you're doing right triangle trig, theta is always got to be less than or equal to 90 and greater than or equal to 0. So exact values, that's like numbers on the unit circle. So what's the sine of 30? Anyone remember what that is? And to get these, you look at a special right triangle. Where's my special right triangle? This is very special. If I can find it. There it is. So here's a special right triangle. We'll just draw it like this. Okay?
Yeah.
And we'll call this a 30-degree angle, 60-degree angle, and this is a 90-degree angle. So the sine of 30 is, who knows, from your unit circle? 1/2, which is equal to the sine of, in radians, pi over 6. Yeah? No? Yes?
Wait, why is it equal to 1/2?
Why is it equal to 1/2? Let's say this is an equilateral. It's half of an equilateral triangle. Okay? If they say this side is 10, just for kicks, all right? So if I were to take an equilateral triangle, I'm going to erase this in a minute. But this side would be 30, this side would be 60, right? Equilateral triangle, so it's 60, 60, 60, that makes the equilateral triangle, right? So this is 10 over here as well. This whole side is what? 10. So that would make this little side over here what? 5, half of that, right? So then the ratio of this side to that side is 5 to 10, 1/2. No matter what length I make this side, that ratio is always going to hold the same. Follow? Okay? So that's why that ratio is 1/2, and that's where that stuff on your unit circle. That's where that stuff on your unit circle comes from. What's the cosine of 30 degrees? Cosine of 30 degrees. That's cheating. 0.866. Okay? Watch. Do Pythagorean theorem. Okay? B. 5 squared. Yeah, I'm not going to. You should have learned this, or we did learn it in geometry. 10 squared. So b squared equals 100 minus 5 squared, right? B squared equals 75. I'm just going to do this. Whether you remember this or not is up to you. B squared equals square root of 75. This can be broken into the square root of 25 times the square root of 3, which is equal to 5 times the square root of 3. So this side has a lot of little math there, but this side over here is 5 square root of 3. Okay? So the ratio of the adjacent side to the hypotenuse side is 5, in this case, is 5 root of 3 over 10, which reduces to square root of 3 over 2. See that? And it doesn't matter. So you get these values off your unit circle. Okay? Because it doesn't matter what length this side is, that ratio, that's what the trig stuff is all about. The ratio of the opposite side, or the adjacent side to the hypotenuse side, when this angle is 60 degrees, is all, or this angle is 30 degrees, is always going to be root of 3 over 2. It doesn't matter if I call this 12 or 27 or whatever it is. When those angles are set, that ratio is always going to be the same, and use that to solve problems. So that cosine of 30 is root of 3 over 2. What's the tangent of 30? Or pi over 6 radians? Well, looking at this picture, what's it going to be? Opposite over adjacent, what's that? It reduced, no, it's not quite. It's 5 over 5 root of 3, which is 1 over root of 3, which if I rationalize that, I'm going to change colors. Okay? By multiplying by root of 3 over root of 3, I get root of 3 over 3. So that is, you should, I would say, just memorize these ones. Okay? Well, the 45s also. Tangent 30 is root of 3 over 3. Okay? Now, if you flip them, okay, you will get the cosecant. So what's the cosecant of pi over 6? What's the cosecant of pi over 6? Flip of that, 2. What's the secant of pi over 6? Flip this. If you flip that and you rationalize it, you get square root of 3. Okay? And the tangent.
Wait a minute.
Yeah. The tangent.
Wait, go back to secant.
Oh no, you don't. You don't. You get 2 root 3 over 3. I'm sorry. Let's do it. Yeah, you get 2 root of 3 over 3. So secant of pi over 6 is equal to the reciprocal of that. So that's 2 root of 3. Sorry, it's root of 3 over 2. Root of 3 over 2. Let me erase this. Times, I want to flip it or over, right? So that becomes, I'm going to do it up here, 2 over square root of 3. And then I rationalize the denominator by multiplying by root of 3 over root of 3. And that gives me 2 root of 3 over 3. That's the secant of pi over 6 is 2 root of 3 over 3. So you should be able to figure those out. But based on a unit circle, I wouldn't do it based on, based on a triangle whose radius is 1, because it's just kind of easier. It's easier to do you don't have to reduce things. Okay? And then to find the other ones, secant we did, cosecant we did, tangent of pi over 6. If you flipped and you multiplied, comes out to be, if you flip, where's this tangent, or cotangent of pi over 6, okay, is the reciprocal of tangent. So that's equal to 3 over the square root of 3. And when I rationalize the denominator by multiplying by root of 3 over root of 3, I get 3 root of 3 over 3, which is just what?
3.
Root of 3. Okay? So you have cosine, tangent, cosecant, secant, and cotangent. Now with the cofunctions are the functions that if I were here instead. Okay? So the cosine of 60 degrees is the same as the sine of 90 minus 60 degrees. Cosine of 60 is the same as a sine of 90 minus 60. Okay? And the and the tangent of 60 is the same as the cotangent of 90 minus 60. Degrees. And the secant of 60 is the same as the cosecant of 90 minus 60. Okay? So if I want to find all these things, all I really have to do is to find the cosine of 60, all I have to do is look at the sine of 30. Okay? And so if I want all these numbers, cosecant of 60 is equal to the sine of 90 minus its cofunction. Okay? So that's going to be what? What's this going to be? What's the sine of 30? What's the sine of 30? 1/2. Tangent of 60 is the same as the cotangent of 30. Okay? Tangent of 60 is the same as the cotangent of 30. What did we say the cotangent of 30 was? Root of 3. So that's root of 3. The secant of 60 is the same as the cosecant of 30. Now what did we figure out that the cosecant of 30 was? Did we do that one? Can I drag this somehow? Can I get to over here? How do I get back? Oh, like this. Okay? Cosecant of 30 is 2. Okay? So the secant of 60 is also 2. Yeah? So the cofunctions are the complement of its function. Okay, so cosine of 60 is the same as sine of 30. Cosine of 43 would be exactly the same as if I did the sine of what? 47 degrees and so forth. Because sine of 30, if I'm standing here, is 5/10, right? Cosine of 60, if I'm standing here, is also 5/10. See that, the way that works? That's why the cofunctions and those things are that way. Okay, so do you guys know how to solve problems with this? Hello? You know how to solve problems with this?
You should show us.
Show us a couple. So what if I want to find the height of a tower? That's why you would want to do this, because you're a surveyor and you see a mountain and you say, how high is that mountain? Have you ever wondered that? Have you ever wondered that? That's not how the mountains go. Mountains go like, how do mountains go? Sort of like this. Here's a mountain. Let's say that this is a mountain. And you are standing way over here, and you drive your car to the bottom of the mountain, and you notice that it's 400 miles to the base of the mountain. I don't know how you get to the base of the mountain, but maybe it's 400 feet. Let's say this is 400 feet. And you look up, and you see an airplane. Okay? Okay, there's an airplane. And you want to know, what? That's a good airplane. What are you making fun of me for? Okay? It's got little wingy thingies going that way. All right? And you look up through your clinometer measuring device, and you notice that's 10 degrees. And I want to know, how high is my airplane? Have you solved problems like this in trigonometry before? So you would go at which trig ratio am I going to use here? What and what? This is the what side? Very good. Tangent, who said that? Very good, Ben. So how would I set that up? Tangent of 10 degrees equals h over 400. And fortunately for you, someone already figured out what the ratio of this side to this side is when that angle is 10 degrees. Okay, and that ratio is in your calculator. When I was in high school, we used to have to look in the back of the books, and they'd say, okay, when that angle is 10 degrees, the tangent is this, and then we'd have to use a process called extrapolating to figure out what that ratio was and all this kind of stuff. Way more complicated back then. Okay, so then I will multiply 400 times the tangent of 10, and I would get my answer, and that answer would be what? Can you do that on your calculator? Make sure for this one at least, you're in degree mode. All right? So here we go. 400 times 10 times tangent of 10, and I get out that airplane is 70 feet high, and everyone's going to die. But 70 feet, not 70 degrees. Okay? So he's 70 feet. That's not very high. So anyway, your homework is on my website, but I have it. I'll put it up. Okay? I have homework is I think I got it on here. Advanced pre-calc. I updated last night. Let's see if it came out. There it is. I could even make it bigger. Okay. Part 1, partial. So again, it's kind of a lot, but they're quickies. Okay, most of them. Okay, so that's 1 through 6 are just kind of, do you understand the stuff? 8 through 36 are you have to find the sine, cosine, tangent, and that kind of stuff. And then 73, 76, 80, and 81 are ones where it's like a word problem. Well, not all of them. I think just 80 and 81 are word problems. All right? All right. Do your homework. It's not due till Thursday, so you got plenty of time. And I never started, no, I started before.